Hello, you with us?
Oh, hi there. Hello, let me start my camera. Yeah, there we are. Hi
Nice to
there.
meet you and welcome. Just
Thank you.
by curiosity, do you know Harry and Hank?
Oh yeah, I do. I've met Hank a few times, and I actually used to work with Henry on the island of Texel. I worked there for almost 4 years. So yeah, I do know him pretty well.
And the second curiosity, do you also live on an island, as Harry does, or?
No, 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 no. I would love to. I just live in a mid-size, ordinary town.
Okay, thank you so much. So serverless is indeed a hot topic today, right? But that probably complicates things when thinking of deployments and DevOps and similar things. So, well, with this trigger in mind, I'll just phase off and let you take over the scene.
All right, I will.
Thank you.
Let me start sharing. There we are. All right, so the next 40 to 45 minutes, we're going to talk about KEDA. And KEDA stands for Kubernetes-based event-driven autoscaling. So what KEDA is it's a component which you can run on top of Kubernetes, and it allows you to do event-driven scaling. And it really lives up to the promise in that it makes it really simple to do so, as I hope you will see in the demos that I prepared. So the scaling itself is done by something we call a scalar. And a scalar is simply put just some code that can read some kind of event source and provide Kubernetes with the metrics to do scaling based on. So we will deep dive into each of these areas in the upcoming demos. So a little bit about me. My name is Erwin Staal. I'm from the Netherlands. I live in a town called Assen. And I'm an Azure architect and DevOps consultant, and I work for a company called 4.net. And as you can probably guess from that name, we do stuff around the whole Microsoft ecosystem, and especially .NET development. But nowadays also a lot of Azure consultancy, DevOps consultancy, but we also build applications in Angular, for example. All right, so to make sure that anyone who hasn't done anything with Kubernetes before can still follow along, I'm gonna take the next 5 minutes to quickly explain a bit more about containers and Kubernetes itself, just so you all have enough information to understand where KEDA fits in the picture. So what actually is a container? Well, simply put, you could say that a container is a very lightweight standalone package which contains every bit and byte your application needs to actually run. So it contains your application, but it also contains the runtime it might need, the SDK. It also contains any other application or system tool your application might need to run. It could also include settings, etc., etc. So if you would then grab a machine, a virtual machine, for example, and you put Docker on it, your application can run on that VM just by installing Docker. So that's really cool. It allows you to run your application wherever you want with just installing Docker. But doing that in production is a bit more complicated. We then need something to manage all those containers for us, because in production we want stuff like high availability and resiliency, etc. So we need something to orchestrate and manage our workload. That's where Kubernetes comes into the picture. It's one of the container orchestrators you find out there, and it's by far the most popular and most used one. So the basics of Kubernetes lie in the notion of having a master and a few workers. So the master you see over here is responsible for making sure your workload actually runs on any of the workers. So the workers are responsible for actually running your workload. So if you would want to deploy an application into Kubernetes, you have to write something like this YAML file on screen here. This is a very, very simple example. It probably doesn't even work because there's stuff missing, but you get the idea. So the most important stuff is there, like it specifies which image you actually want to run, which application do you want to run. And in this example, that's a Grafana image, which is some dashboarding tool. You also get to specify some parameters that your application needs to run. So there's a container port, how can we reach it? And there's also the notion of replicas, which tells Kubernetes something about how many instances of your application do you want to run. And the beauty of the system is that it's a desired state system. So you provide Kubernetes with this definition, with this YAML file, then Kubernetes, the master, will then try to make sure that whatever you specified in that file actually becomes running on your cluster. So if you would deploy that, it would nicely run these 3 instances, the 3 replicas on each of the workers to split the work across the workers and be high available. But what happens if one of those workers dies? It has a power outage or whatever. Kubernetes then still wants to make sure that your desired state is still the state your application is in. So it will notice that the worker is gone, and it will then try to transfer that particular work that was on it to another worker to make sure it's still your state as you wanted it. So that's a bit of the basics of Kubernetes. I think we actually made it in 5 minutes. So let's move a little bit to where KEDA fits in. And that's obviously in scaling based on events. So if you look at scaling in any product really, then you could say that there's 2 ways in which you could do scaling. There's both the horizontal scaling and the vertical scaling. By horizontal, we mean that we could simply add additional nodes if we need more capacity. So you just add more virtual machines, for example. And if you happen to use a cloud environment, then that's quite easy, obviously. So there's also the way you could also scale vertically. And what we mean by that is that if you need more performance, you need more resources, you add more CPUs or more memory to your existing machines and simply make them bigger by doing that. So in Kubernetes, if you combine the 2, you get this table over here. So you can do scaling both horizontally and vertically. And what that means is, for example, that you can scale the number of nodes, your number of workers, but you could also scale the number of pods. And a pod is what we in Kubernetes basically call a running container. There's a bit more to it, but for now you could just say that a pod is a running container. So we could scale the number of pods to get a bit more performance out of the platform. You could also scale vertically, so you could change the size of your nodes, and you could even change the size of your pods, because you can limit what, in terms of resources, a pod is allowed to use. So you could change that and actually make it a bit bigger if you need to. The thing is, however, that the vertical scaling is still an alpha and beta feature, so that's not really production ready. So depending on where you run your Kubernetes cluster in Azure, for example, or Google Cloud, you might or might not even be able to use that type of scaling. So it's a bit limited at this moment in time. But the really big problem with the scaling in Kubernetes by default is that it can only react to the symptom and not the actual cause. And what I mean by that is that scaling in Kubernetes often happens based on your CPU usage or your memory usage. There are a bit more options, but again, those aren't generally available yet. The CPU scaling is. So scaling is mostly done based on CPU usage. And so that's just a symptom. That's what happens when you need more power. It's not the reason why you need more. And that's where KEDA comes in. Because KEDA can do that. KEDA can scale your pods based on events in some kind of source. So you can install KEDA into any cluster, into an existing one or in a new one, doesn't matter. And it's very extensible and pluggable and has this notion of the Scalars we already talked about. to grab the metrics from any type of event source and feed that into Kubernetes to do scaling. We'll look at a few examples of Scalars later on to make it a bit more concrete. So what it does, it monitors the rate of events proactively on any of those sources to then scale your containers based on it. It feeds that data into the APIs of Kubernetes. So KEDA itself is actually pretty small because it uses whatever it can from Kubernetes itself to not overdo it, which is a great thing. It just uses the existing Kubernetes APIs to drive the actual scaling. A nice benefit you get from using KEDA is the fact that you can also scale your containers down to and from 0. And that is something Kubernetes cannot do by default. You always have one instance of your pod, but with KEDA, you can actually scale down to 0, which makes sense, right? It could perfectly be that you have a queue which is empty for most of the day, and it would be a waste of resources to always have a pod running without any event on your queue. So that's a great additional option. And the last statement over there, it's up to the deployment to consume the events from the actual source. And we will dive a bit into what that means later on. So let's first have a look at the architecture diagram of KEDA to go a bit more in what's actually running on your Kubernetes cluster. So as you can see here, it nicely fits in and talks to Kubernetes stuff. And you can see that KEDA itself actually consists of three main components: the metrics adapter, the controller, and we already mentioned the scalars. So as you can see, it just uses the built-in horizontal pod autoscaler to drive the actual scaling. At least it does when it can scale from 1 up to whatever and back to 1. As I mentioned, KEDA is able to actually scale down to 0 and from 0. So that is something KEDA actually does for you, whereas the horizontal pod autoscaler is responsible for scaling from 1 and up. So it also, the scalars are the things that actually talk to your external source to make the triggers, to get the triggers. And it's then also your pods that have to talk to the event source to get the actual data. So let's have a look at the list of currently available scalars. And this list grows like every month. So I'm not even sure if it's up to date here. But as you can see, there's quite a lot of scalars available. And I most of the time work with Azure stuff, Microsoft stuff. But as you can see, KEDA doesn't just work with Azure. It works with a lot of third-party scalars as well. So you can do stuff on AWS, you can do stuff on Google Cloud. You can actually run queries against MySQL, for example, and do scaling based on the outcome of such a query. So you can do a lot of stuff here, and not just Azure or Azure Functions, but there's a lot of other options as well. All right, so let's dive a bit into the part of the diagram that touched on how KEDA actually talks to your events, to your sources. So we'll first have a look at how KEDA does it, and then we have a look at how alternatives to KEDA do the type of scaling. So this first little diagram shows the flow and how KEDA works. So what happens is that KEDA will pull your queue, for example, your event source, to see if there's any work on them. If there is anything to do, KEDA will start scaling your application. It will start to spawn your pods and start scaling them. And it's then up to your app to actually go into the queue and fetch the actual item from the queue. So KEDA only does the scaling. It doesn't fetch the data from the queue and give it to your app. It just tells your app to start running, and then you are responsible for grabbing the data from the queue. So that means that you still need to work with the SDKs, for example, that come with a particular type of queue. But it also does give you the power that you get from working with the SDK directly. And this is what an alternative to KEDA could look like. There's quite a few alternatives in the market that you could go for as well. And some of them actually go for this type of approach. And what you see there is that the alternatives go to the queue to see if there's any work. If there is any work, they grab that data from the queue and give it to your app over HTTP. So your app doesn't need to go to the queue itself anymore. It already gets the data from whatever runs on your Kubernetes cluster. So the benefit to that is that your application just needs to talk HTTP, and you don't need to worry about using the SDKs or of the actual event source you're working with. So that could be quite powerful because it's a bit easier than what KEDA does. You cannot, however, use all the pros that come with talking to your queue directly. So that's a good thing to know about how KEDA works and how alternatives work, and you get to pick whatever is best in your scenario. All right, so almost time for the first demo. And in the first demo, I'm gonna build an Azure function, and we're gonna run that Azure function on Kubernetes in the Azure cloud. And we're gonna make sure that KEDA will start scaling our Azure function. So I created an AKS cluster in the Azure cloud, but I also added something called the Azure virtual nodes. And adding a virtual node to an AKS cluster in Azure means that you start using Azure container instances. So, and that's a pretty cool thing because AKS gives you dedicated nodes to run your workload. So that's just the 24/7 same price to run your workload. And the Azure container instances, that's a service in Azure that you can just give a container to run and it will simply start running it without the whole AKS cluster stuff around it. But the best thing is that you can actually use it simultaneously and together. So what we can do is that we can deploy something, an application to Kubernetes, and Kubernetes will then actually decide where that needs to run. If that would nicely fit on AKS, or if that workload would nicely fit in an Azure container instance. And especially for the things we're talking about today, running containers and scaling them based on events, the Azure container instances is really convenient because you often find yourself when, for example, having a queue that for most of the day there's nothing on that queue, and then suddenly over 1,000 items come in that queue and you need to do a lot of work. If you would start scaling based on those 1,000 items on your AKS cluster, you might bring down whatever was already running on that cluster. So being able to give that particular work to the Azure container instances is quite powerful. And you can still do that talking to a single endpoint in Azure, and that endpoint will simply make the decision where to run your actual workload. So stuff that runs 24/7 probably should run on AKS. Stuff that runs pretty shortly or runs just for a short period of time should go on to Azure container instances. That's a bit more expensive than running if you would run that 24 hours compared to AKS. So there's a trade-off between the two. All right, let's dive into a little demo. So we're first going to create an Azure function and see that run on Kubernetes and get that scaling. So once again, KEDA isn't just about Azure functions. You can run kind of whatever you want on KEDA as long as it's a container and have it scaled. But the beauty of Azure functions is that it gives you this nice runtime and this very powerful way of working with queues, etc. in Azure, for example. So we're going to have a look at what that looks like. So to start with one, you have to create a new one on the command line. So I'm going to use func, which is the Azure Functions CLI. Say init, and I want to create a function in my current directory, and I want to run it in a Docker container. You could actually run an Azure function, obviously, on Azure directly. You don't need a container to do that. But if you want to run an Azure function on Kubernetes, in Azure or on-prem or in the Google Cloud, doesn't matter, you need to tell it that you actually want to do that inside of a Docker container. So it asks me to specify the language I want to use. As you can see, there's a few options there. That didn't work out, probably because I didn't create a new folder. So let's do that. Thought I emptied it, but apparently I did not. So let's create a new one. Okay, 2 shaded. All right, let's rerun that init command. All right, so again, I'm gonna pick .NET. As you can see, there's multiple other flavors as well. For some more infrastructure-related stuff, PowerShell might probably be a very good option. So now that it's done, it has created a Docker file. I should probably open a new code window. Can I actually do that from here? Yeah. All right, awesome. Let's close this one. Let's grab me a terminal. Right, so as you can see, a few resources were created for me, amongst which is the Docker file we're actually gonna need. And as you can see, that one actually uses the Azure Functions image to run the stuff later on. So that now has created my Docker file, etc., and stuff to run, but I haven't created an actual Azure function yet. To do that, I have to run func new, and that will ask me what kind of trigger, what kind of template I want to use. So as you can see, there's quite a lot of different triggers templates available, and we're gonna pick the Q trigger. It wants to have a name, so let's be original. I call it Hello KEDA, and it will now start to generate that function for me as a C# function that works on the Azure Q. So there's an additional file added to my solution folder, and this is the actual Azure function that we can run. So for who've never seen an Azure function, this is a very, very simple example of one. It specifies the name of your function, which you would also then later on see in Azure, for example. This is how it specifies the particular trigger that's used to trigger your function. So as mentioned before, we're using a Q trigger here. You have to specify the name of the queue you're using, and you have to specify the connection string to that actual queue so that it knows which queue to read the data from. And that's all there's to it. Once you specify that information, you can start coding here and do whatever you want with the data that actually is coming in. And the data always comes in as a string, which probably be some kind of JSON representation, which you can then convert into a real object, for example. All right, so that's a very, very simple definition. Now, if you would want to deploy that function, we could again use the Azure Functions CLI, and it goes something like this: func Kubernetes deploy. You then need to specify a name for your function. So let's call it Hello KEDA again. You need to specify the repository, your Docker repository you're going to use, because this function is then going to be built into a container or an image. Actually, you need to push that image into your repository and then deploy that into your Kubernetes cluster. And the func Kubernetes deploy command does all of that for you. So I need to specify my registry, which is Erwin Staal. And if I now would hit enter, it would start building my image. It would push that into my Docker registry, and it would start to deploy my application, this Azure function, into my Kubernetes cluster. But quite often you would want to have a bit more power over how that gets actually deployed. So what you can do is specify the dry run flag and say, please put all of the stuff you're actually gonna do into my YAML file. And you probably don't want to see me typing and having that being generated, etc. So I already created an example which contains that particular output. So when I would run that command, that would give me this deploy.yaml file. And as you can see, that specifies all the stuff that need to be deployed into my Kubernetes cluster to get this Azure function run and scaled using KEDA. So whoever is a bit familiar with these kind of files and deployment into Kubernetes probably recognizes the part over here. This is a secret, and this secret actually contains our connection string into the Azure storage queue. So that's the connection string, which has a particular name. So that's the secret. Then down here, there's a deployment being created. And that's, again, a default thing in Kubernetes, which specifies how to run your application, basically. So as you can see, the image is being specified over here on my Docker registry. And here's the specification of the secret you wanna use. So the only thing here that is KEDA specific is the stuff down here. So we now have something called a scaled object, and that allows us to specify the workload we want to scale based on the events. So we have to specify a few things here, and most important ones are probably down here. This is where you specify the trigger you're going to use. So again, that's the Azure queue trigger. For example, you get to specify the connection string to that particular queue, which again is the secret we already saw on top of the file. We also get to specify how KEDA should be scaling our workload. So the polling interval stands for how many times a second, or in how many seconds it should poll your queue to see how many events there are. The cooldown period specifies how long it should wait after your queue is empty to scale down, to start removing your workload. And you can specify the minimum replicant count and the maximum replicant count. So again, I've specified the 0 here, which is something that's not possible by default in Kubernetes. But you can do that with KEDA. All right, so if I would now want to deploy this YAML file, I would have to use a few Kubernetes commands to do that. But I already did that because it takes a bit of time to create that image and to deploy it and push it, etc. So I already have that one running on my Kubernetes cluster. So let's see if that's actually up and live. It is. These are the nodes that are currently running in my cluster. So as you can see, there's an AKS agent pool, and there's also the virtual node we already talked about. So there's those two things are actually two different services in Azure, but I can talk to them using the same kubectl commands. So that's really cool. So let's see what is actually already running there. Let's see if there's already any pods. And there aren't any pods, which makes sense because the pods were scaled down to 0, so there are none. But if you look a bit further, we can also try to see the definition of the horizontal pod autoscaler. And as you can see, there has one been deployed for this particular application. And something that has cost me a few hours when I started with KEDA is the fact that it still says minimal pods 1 in this horizontal pod autoscaler definition. And that simply is because Kubernetes by default doesn't understand scaling down to 0. But I thought I was doing something wrong and it had to be some kind of bug or whatever. So I spent a few hours trying to figure that out. All right, so let's have a look at the deployment and what that actually looks like. Well, so the deployment is also there. And as you can see, a 0 from 0 are ready, which is actually what we want, right? All right, so now it's time to actually start seeing some scaling in action. So let's do this again, but then let's watch the output of that command. deploy elements. All right, so we'll leave that one open. And then on the background, I'll start a simple program that actually posts a few messages on my particular queue. Let's have that going. And it starts filling around 100 items in a particular queue. And it shouldn't take too long for us to actually start KEDA scaling out. As you can already see, it's doing it right now. And it's scaling rather quickly now because I've set the polling interval to a 5 here. So it's going pretty quickly. It takes a bit of time to get your container deployed on the Azure container instance. That does take a bit longer than getting something deployed on AKS because something new has to create it for you. So it takes a bit longer. We can actually go into the Azure portal and see what it looks like over there. So this is my AKS cluster. And if you would go to workloads over here, which is a nice new feature, you see that my hello KEDA workload down here actually started scaling. And if we dive into that, we can see that a lot of pods have been created. A few of them are actually already running and got an IP address, and some of them are still waiting to be created and have an IP address assigned. So I think actually that my queue probably is already empty again. No, it's still doing a bit of work. So that shouldn't take too long. The function itself doesn't really do anything. Just prints the message on the queue. And as you can see, KEDA already started scaling down to 0 again because there are no more items on the queue. So if we would refresh this overview over here, you would also see that there's no pods available anymore because they have been deleted again since they weren't needed anymore. All right, so that's a very quick demo of creating an Azure function using the power of that SDK to grab some data from your queue. As you can see, I didn't write any specific code to fetch an item from the queue. So doing that with an Azure function is very, very easy. And I got to scale that based on the number of events on my queue using KEDA. So that's pretty powerful. All right, let's go into the second demo. And I'm gonna go quickly back to the slides here to explain a bit about the next demo. So I now showed you a KEDA running on AKS, but you can actually run it wherever you want. So it's not Azure specific, it's not Microsoft specific. So the next demo I will do on my local machine, and I'll use K3s and K3d to do that. And K3s is a lightweight version of Kubernetes, in which they replaced a few of the core components of Kubernetes with smaller ones. And that allows you to, and enables you to run a Kubernetes cluster on your local development machine. So that is something that you couldn't normally do with the full-blown Kubernetes. But with K3s you can, because they are actually running Kubernetes inside of a Docker container. So if you just spawn multiple of these K3s containers, you actually get multiple nodes. And K3d is a tool that can help you do that. So it's a very easy, lightweight way to run a Kubernetes cluster on your laptop with more than one node to make it a bit more realistic. All right, so the next demo we're going to look at running on my local laptop is one that uses the Prometheus scaler. And Prometheus is a time series database, and we can do scaling based on data in that database. So this is what that conceptually looks like. So there's a .NET Core app, a very simple one that I've been writing, and Prometheus grabs some data from that .NET Core application, saves it into its time series database, and then KEDA will run a query on top of Prometheus to get a metric out of it. And based on that metric, my application will get scaled. Let's have a quick look at what that looks like. I need another. Here we are. All right, so the application itself is just a simple .NET Core API, which writes events to Prometheus. And the only thing I actually want to show you here in this demo is what the deployment file, the YAML file looks like. So again, we have a scaled object like we did in the previous example. But this time the trigger section is different because we're using a different event source. So this time we are using Prometheus, we're using that scalar. And as you can see, there's a few different parameters in this one than compared to the Azure Q version. So you have to specify where your Prometheus service lives, for example. You also have to specify the query that KEDA will run against Prometheus to get its metric and scale based upon. So if we then have a look at what that looks like, let me quickly see. Yeah. All right, just dragging in a few additional consoles to let you see what's actually going on here. So again, there's a few applications running on my local cluster. This is actually a local cluster using K3S and a combination of K3D. So that's pretty cool. This is all running locally. And this is actually the .NET Core Prom app is actually the app we're going to scale. And it's a .NET Core API. So all we need to do is make sure we need to make a few API requests to get it going. So I'm using a tool called Hey to kind of load test that API of mine. So if I start it, it will start making a few requests against my API. And we can then actually go into Prometheus to see if that's actually resulting in any data. So let's see how that's going. The query over here is the same one that was specified in the KEDA definition. So KEDA is using the exact same one. And as you can see, that's returning data on how many invocations there are. So it shouldn't take too long before we actually see KEDA, and there it goes. KEDA starts scaling the application based on the metrics that come from the Prometheus data. And as you can see, Hey is already done, and it nicely gives us a bit of information on all of the calls it has been doing and the response times, etc. So that's a really cool tool to get trying stuff like this. All right, so KEDA now nicely started scaling my web application, my API, based on the events that were stored inside of the Prometheus database. And that's a really powerful scalar, actually, because you can almost put whatever metric you want into Kubernetes or into Prometheus. It could come from anywhere. It's an open source tool that's used a lot. There's a lot of connectors into Prometheus to put data and put metrics into it. So the combination between Prometheus and KEDA is actually really, really powerful. So you can see that Hey is done. So the number of requests towards my API are going down again. And somewhere in the next few minutes, KEDA will start scaling down my app again. All right, time for one small last demo. Let me find the final window. So in the first example, I used AKS to run Kubernetes and run KEDA. And whenever you do that, whenever you run your Kubernetes cluster in the cloud, that cloud also manages your machines for you. So it manages my workers, for example. AKS will make sure, and the Azure Cloud will make sure that my machines get patched whenever they need to stay up to date with security patches, for example. That also means that AKS will add and remove workers and nodes kind of whenever it pleases. So it could just add a new node and then take down another one to start patching, etc. Imagine that you are running some kind of code on your cluster that takes literally hours to run, and which is very hard to reshoot. So imagine that there's something on your queue which triggers you to do some work, and that work actually takes you hours to complete. If in the meantime Kubernetes decides to replace your worker, or the Azure Cloud does because they are going to patch your machine, for example, your running workload gets killed. So your long-running process will get killed somewhere in the middle, and it's quite hard to resume that. So Kubernetes actually has something built in to keep you going, and that's what we call a job. So if you want to deploy something into Kubernetes, which needs to be long-running, you should deploy that as something we call a job. And the beauty with KEDA is that we can also scale and create these jobs based on events. So imagine you have items on a queue, and those items actually represent encoding or decoding a very large file, for example. You could then have that been done in a job, which gets scaled using KEDA. So what I did here is I wrote a very simple .NET Core console application, which fetches an item from the queue and simply writes a message to the command line. So a very simple .NET Core application. I then need, again, a YAML file to specify how KEDA should be scaled. So again, we have a scaled object, but this time it looks a bit different because this time it's about a job instead of a queue trigger, etc. So there's a few different parameters you have to set here, but the idea is the same. You have to specify how you want your workload to get scaled, basically. So let's quickly see that in action. Using this command, we can see the jobs already running on our Kubernetes cluster. And if I would then go into my queue and add a simple test message there, it shouldn't take too long before KEDA sees there's a message and it spawns a new job. As you can see, it spawns a new one every time because they're different. And it takes a bit of time for it to complete, and it's been completed. So it's also been shut down and removed. So that's the third demo. And with that, I'm also out of time. So we're gonna quickly go back to my sheets. So what we've seen is a few different examples of how you can scale your workload using KEDA, whether it being Azure Functions or a whatever API or even a console application, doesn't really matter. As long as it's in a container running on Kubernetes, you could use KEDA to scale it out based on events. Really cool tech. So thanks for watching, everyone. I hope you enjoyed it. If you have questions afterwards, please use the information here to contact me. And on my blog, there's actually a blog post on how to do that first demo. So if you want to do it yourself, there's a full instruction on how to create the cluster, write your first function, and deploy that and scale it using KEDA. So please go over there if you're interested. All right, back to you, Florian.
Thank you, Erwin. Let's take a couple of questions then. So the first one would be, how mature is framework?
That's a good question. They actually reached version 1.0 somewhere in November last year, if I'm correct. and they are really going pretty fast. So it's really a mature product. There's a few big companies behind it, like Microsoft, etc. And if you go to their website, KEDA.sh, if I'm correct, then you will actually find a list of pretty big companies that use KEDA in production. So I would say it's pretty mature. I haven't really seen anything weird or whatever while using it.
Have you experienced any issues with it so far, or are you aware of things that we should avoid maybe, or advantages?
No, not really. I actually had a problem while preparing these demos yesterday, but that was a problem which was more in the AKS and Azure Container Instances stuff than in KEDA itself. So no, like I already mentioned in the talk, KEDA itself is pretty small. It's actually pretty simple. There isn't too much to it. There isn't too much that could actually break. So that's really good. So no, I haven't actually had any problems with it.
Mm-hmm. So you mentioned it's small. So the next question would have been about the learning curve. How did you perceive that?
Actually, pretty simple. When I found out about KEDA, I was looking for a product to run actually serverless functions and Azure functions on an on-premise Kubernetes environment. And while I was looking for a product that could do that for me, I've been looking at a few of the alternatives, and KEDA actually was the most simple one to get started with. If you later on would go over to my blog, you can actually see that it's quite easy to do. Not too many commands and stuff you actually need to know to get started. Deploying KEDA into Kubernetes, for example, is one line of code. So that's really simple.
Okay, now we have a more specific question related to a real life scenario. So imagine you have a Black Friday, 1,000 orders in 10 seconds. The container which does fetches the order is in processing mode. The only chance to have it back is by restarting it. Containers are also scalable. Is KEDA, I don't know, is it possible to handle this situation with KEDA? I mean, can KEDA make the difference in this scenario? I've also copy and pasted the question in your chat, so you can maybe read it again if it's not. It's a very specific question, so.
I think I do get it. What's actually important here is that that KEDA is only responsible for scaling your application up and down. As I mentioned in my talk, it doesn't actually fetch the data from your queue or whatever. So in this example, if any process would get stuck, and you would be using an Azure function with a queue trigger, for example, that would mean that that function grabs the item from the queue, and the item on the queue gets hidden. It doesn't get removed from the queue, it gets hidden because there's a process working on it. So if that process would hang, and you would restart or delete the container, in just a few minutes, that item would simply be put back on the queue. KEDA would see that again and would start scaling again based on the items on the queue. So I would say this isn't so much a KEDA thing. It's about how you as a consumer handle whatever is on your queue and whenever that gets deleted, etc.
Okay. Yeah, it makes sense. And the other question that we have is, does KEDA keep some sort of warm containers? They can handle load spikes?
You could, yeah, if you in the definition in the YAML file, you get to specify the minimum and the maximum replica count. You could simply set that minimum to 5, for example, and that would mean that whenever you deploy a new image to your Kubernetes cluster, it will make sure that 5 containers already start running and are fully ready to pick up the work. Because it could take a bit of time to get your first container running. So you might actually want to do that to always have one. Yeah.
Okay, great. So, and we should jump into the break right now. And if there will be any other questions, hope the audience will contact you directly.
Yep, that would be good.
Thank you so much. I'm looking forward to the next time already. I really enjoyed your presentation. I was not aware of this tool, so now I have a basic understanding of it.
Yep. All right, thanks for having me.
Okay, thank you so much.